gosh. User index. Capital. Isn't it like... something like that? This is awful. I'm gonna rename this. I dumb? This has a crazy high acceptance percentage, and I'm not getting it. I'm definitely overthinking this. Okay, thank God. There's gotta be an easier way to do this. Oh, event space, oh, event time. Like, I feel like there's definitely a way to do this. Maybe I'm just dumb. Optimizations. How else would we store? We have to have a way to store previous iterations in a constant time, which I don't think is possible. So you'd have to mathematically do it. But I don't. There's no way to determine the mathematical. Yeah. Oh, you know what? This is. That's dumb. You use a frequency array, I guess. I see. I'm gonna try to do this with the frequency array. So we have n equals length, int output equals new int, and boolean visited equals new boolean equals 0, must be less than Oh, this is still constant. This is still this is linear space. This is also linear space. Wow. Yep. Wow, I got optimal. Even though that took like way too long. I'm surprised it's so high. Oh, it's so high because the constraints. People just like brute force it. Okay, that's why it's so high. Interesting. Alright, graphs. Let's see. Can we finish this? I think we can. Hey, so we're gonna get a count variable and then iterate throughout the grid. 0 I is grid dot length I plus 5. And if the grid's current value equals 1, we're going to delete island ij grid and then count plus plus. Return count. Public void delete island in row and call. We're gonna have a lot of this. Char grid if row is less than 0. Grid row length. Call equals no. And then we just do rerun delete island row plus 1 call grid row minus 1 call grid row call plus 1 grid row call minus 1 grid This happens in O of n times m. N times m. N times m. Let's just double check that actually. Beautiful. Beautiful. We're going to have in output equals 0 and iterate throughout the entire grid. If grid ij equals 1, output equals math.max, output and delete island, ij grid, return output, public int delete island, int row, int call, int grid. If row is less than 0 or call is less than 0 or row is greater than or equal to grid dot length, call is greater than or equal to grid row dot length, return grid row call equals 0, return grid row call equals 0, return 1 plus delete island. Call grid plus row minus 1 call grid plus row call plus 1 grid rel call -1 grid. Yeah, something like that. Oh. Yep, and this is the same algorithm, so O of n times m. Okay, so here we topologically iterate. I don't even know why I say that anymore. It's just BFS. If node equals null, no. Q node Q equals new linked list. Q dot offer node map node node map equals new hash map. Map dot put node new node dot val. And then while the queue is empty or is not empty, we're gonna take node cur equals q dot poll. For node neighbor in cur dot neighbors. If map dot contains key neighbor, map dot get or put neighbor new node neighbor dot val. And then map dot get cur dot neighbor dot add map dot get neighbor. Yeah, and then return map dot get node. Well, these clearly work. Okay, that's why. Q dot offer map Q dot offer map dot get neighbor. I think that's it. There we go. Beautiful. And what is this? This is it's like O of V plus E, like vertexes and edges. Whoops. Yeah. Okay, cool. I got it right. I kind of guessed though. Let's understand. Yep. Okay. This is hidden, isn't it? Yeah. Oh my gosh. I always mess this one up. I don't know why. Huh. Okay. So for int I equals 0, I has to be less than grid.length, I plus plus. For int j equals 0, j has to be grid I length, j plus plus. If grid ij equals 0, calculate ij grid, and then integer.min value, something like that. Like void calculate row and call and grid min. Actually, no, this is prev. If row is less than 0 or call is less than 0 or row is greater than or equal to grid.length or call is greater than or equal to grid row.length, return if grid row call equals -1, return if grid row call is less than or equal to prev, return so grid row call will then equal maybe this is 0. Yeah, this might be 0. Previous plus 1, so and then calculate row plus 1 call grid prev calculate row minus 1 call grid prev calculate row call plus 1 grid prev calculate row call minus 1 grid prev. There we go. See? Okay, what did I get wrong? We're off by 1. There we go. Oh! I accidentally closed my window. There we go. Okay, that's done. This is also BFS. Oh, this chair is so comfy. I love this chair. So we're going to count the fresh oranges. And then rotten oranges, we're going to keep track of the coordinates. So for int I equals 0, I has to be less than grid.length, I plus plus. For int j equals 0, j has to be less than grid I.length, j plus plus. If grid ij equals what? 1, fresh oranges plus plus. Else if grid j equals 2, rotten oranges to offer new int ij. Yeah. So if fresh orange count equals 0, then we're going to return 0. And then we're going to keep track of the minutes, and while the queue is not empty, sorry. We are going to take the size of the queue, iterate through the size, and then int chords equals queue.poll, row equals chords 0, and call equals chords 1. And then we need to create a array with directions. We do 0, 1, 1, 0, 0, negative 1, negative 1, 0. And then for in directions, int new row equals row plus direction 0, new call equals call plus direction 0, 1. If new row is greater than or equals to 0, and new call is greater than or equals to 0, and new row is less than grid dot length, and new call is less than grid new row dot length. That wasn't clean enough. I gotta do it like this. It was like, there we go. And if grid new row new call equals 2, fresh oranges minus minus q dot offer new ints new row new call, and then what? I think that might be it. Minus plus plus. So return fresh oranges based off of if it equals 0 minutes. Otherwise, I think it's minus 1. Otherwise, negative 1. Oops. Rotten oranges. Oh, I'm dumb. Wow. Oh, I have to also do grid new row new call equals 2. I'm infinitely iterating. There we go. Okay. So actually, what is the... Oh my gosh, you gotta be kidding me. Okay. Without doing that, topologically sorting, it's O of n times m, I think. Yeah. There you go. Okay. Oh my gosh, this one's awful. Okay. So we're gonna have list integer. We're gonna have our output here. And then int n equals heights dot length. in M equals heights 0.length. And then you are going to have Boolean Pacific check, new Boolean NM, Boolean Atlantic check equals new Boolean NM. Okay. Output, what else do we need? I believe that's it. So for in I equals 0, I has to be less than n, I equals plus. Actually, let's, I need to do rows. And calls equals, it's just easier for me to understand that way. And then this will be here, Boolean Pacific check equals new Boolean rows calls, Boolean Atlantic check equals new Boolean rows calls. For an I equal, 0. I has to be less than rows, I plus plus. So we're traversing the rows. We're gonna run DFS on Pacific check, or no, sorry, on rows, columns, Pacific or heights, Pacific check, and integer.min value, and then DFS. I calls -1, heights Atlantic check, integer.min value. For in I equals 0, I has to be less than calls, I plus plus. We're gonna run DFS on 0 I heights Pacific check, integer.min value, DFS 0, no, rows -1 I heights Atlantic check into the integer.min value. And then for 0, I has to be less than rows, I plus plus. For int j equals 0, j has to be less than calls, j plus plus. If grid or if Atlantic check ij and Pacific check ij, output list integer chords equals new array list, chords to add I, chords to add j, output to add chords, return output public void DFS int row int call Pacific int heights Boolean check and pref. So if row is less than 0 or call is less than 0 or row is greater than or equal to heights.length or call is greater than or equal to heights row.length, return. If heights row call is less than proof, return. If check row call, return check row call equals true, DFS row plus 1, call -1, row plus 1, heights check, heights row call, DFS row -1 call, heights check, heights, check, heights row call, DFS row, call +1, heights, check, heights, row, call, DFS row, call -1, heights, check, heights, row, call. Something's off. There. Easy. Easy. Okay, so this is of n times m, n times m, n, m, of n times m, of n squared m, n squared m, n, m squared, n, m. I gotta double check though. DFS. So this worst case goes through everything, n times m. Yeah, so it's either n squared plus m, or n squared times m, or n times m squared. Or it's just n times m. I don't know. Rows plus calls. What does Necode have? So why don't we count the outer loops? What? Oh, I see. Unvisited cells. That's why. So we have a visited array, which allows us to cache our values. Cache our calculations, essentially. Okay, so um so int rows equals board dot length. Oh my gosh. Int calls equals board 0 dot length. For int I equals 0, I has to be less than rows. I plus plus DFS I 0 board. DFS I calls minus 1 board. For int I equals 0, I has to be less than calls. I plus plus. DFS 0 I board. DFS call rows minus 1 I board. For int I equals 0, I has to be less than rows, I plus plus. For int j equals 0, j has to be less than calls, j plus plus. If board ij equals board ij equals x, else if board ij equals b, board ij equals return. Do I need it? No, I don't. Public void DFS int row int call char board if row is less than 0 or call is less than 0 or row is greater than or equal to board dot length or call is greater than board dot length. Return if board ij equals x, row call, return for board row call equals b, board row call equals b, DFS row plus 1 call board, DFS row minus 1 call board, DFS row call plus 1 board, DFS row call minus 1 board. Boom, done. This is the same thing. Oh, what is happening? What happened? Oh, wait. Seems like something is going on. Oh. There we go. Oh, this one's long. We'll do word ladder. Got a few minutes. Oh, this one's kind of long too. Set string. We're gonna make a set of all the strings. Hash set for string word in word list. Set to add word. If set does not contain the end word, we're gonna return 0. Otherwise, we're going to make a queue of strings called queue. Queue offer begin word. While the queue is not empty, int size equals queue dot size. For int I equals 0, I is size I plus plus. Char or string cur equals queue dot poll. Char r equals q or char r equals q or cur chu char array. For in I equals 0, I has to be less than char r dot length I plus plus. Char cur char equals char r. I sound like crazy. Char r cur to char r. Char, cur char, char r I. For char c equals a, c has to be less than or equal to z, c plus plus. Char r I, actually this has to be j. J equals C. String new word equals new string char r. If set or if new word that equals end word, return count equals 0. Count plus plus. Yeah, count plus plus. Return count plus 1. If set dot contains new word, set dot remove new word, queue dot offer new word. Return 0. Damn. Oh. Char r j equals cur char. Surprised it didn't go infinitely. There we go. There's word ladder. Time complexity. Oh no. It's actually quite a bit. Let's see. O of n. That doesn't count. char r O of n times m, where m is average length of the word, or just length of the word, times 26. That doesn't count. This is another m. No, this is the length of each word. So it's n, the number of words, times m times m. So it's m squared times n. What is this space? Complexity of this. I think it's O of m squared, which is the length of the array times, or not. Nine. Nice. Pretty, I mean, the graphs are easy, let's be honest. But, pretty productive.